Okay, so today we're going to be going over probability, and like we just said, probability is very important in math counts and in all math competitions in general. So today we're just going to be focusing on basic probability though. Okay, so for those of you who don't know, what is probability? Probability, it tells us how likely an event is going to occur. And the higher the probability, the greater the chance that it is going to happen. And probability is always a number between 0, which means that it will never happen no matter what, and 1, which means that it is guaranteed to happen no matter what. Okay. So, for example, what is the probability of winning a lottery? So you can just look this up on Google, type in probability of winning a lottery, and just type in the chat what you find.
Depends on the lottery, though. Winning the lottery. Oh yeah, so I got 1 in 13,983,816, and then if it's like Powerball, it's gonna be much lower.
Yeah.
It's really hard to win the lottery. That's like.
Yeah, you can see. Yeah, this is a very low probability because if you like some of the answers you've got, if you divide 1 in like 200 or 300 million, you're going to get a very small number. It's very close to 0, which means that there's a very small chance that you're going to win the lottery, especially some of the big ones. So, yeah, I guess you could put like a frowny face. So, yeah, you're going to have a very low probability of winning the lottery. I mean, if you enter multiple times.
Well, then let's say that one ticket would be a 1 entry. So if you enter 10 times, it's gonna be it really won't help your chances a lot. But I guess you could hope. But oftentimes, a lot of lotteries they like offer smaller prizes, like $10,000 instead of 10 million or $100 to make up that stuff.
But yeah, if you enter multiple times, you're gonna have slightly higher probabilities, but the overall probability is so small that, I mean, yeah.
Yeah, you actually have you're probably always going to lose unless you're extremely lucky.
Yeah.
You're always going to lose money.
Okay, so now we're going to learn how to find probability in math. So we're not going to usually be working with probabilities as small as the lottery, but in general, we're going to be working with, to find the probability of an event happening, we find the number of ways we want the event to happen, and then we divide it by the total number of ways the event can happen. So for example, for some of the lotteries, there's only one winning combination of numbers. And in order to win, you have to get that one combination of numbers. But the total number of ways you can choose numbers, there's like a gazillion different ways you can choose numbers, which is why there's such a small probability of winning a lottery. So let's look at a different example that's not with a lottery. If Joe has 1 red sock, 2 green socks, and 3 blue socks in his drawer, what is the probability that he pulls out a green sock? For this question, it's asking about pulling out a green sock. How many ways are there to pull out a green sock? There are 2 green socks, so there's 2 ways to pull out a green sock. Now, to find the probability of that happening, we divide it by the total number of ways Joe can pull out a sock. So how many total ways can Joe pull out 1 socks? That would be 6, because in total there's 6 socks in his drawer. So then the probability would be 2 divided by 6. 2 green socks divided by the 6 total socks, which equals 1/3. And this is just what I just explained.
Yeah, so probability based, like I kind of like in order to sum up probability, it's just like the total amount of like chosen events or the favorable events over the total possibilities. So there's 6 total possibilities for the sock that Joe can pull out, and there's 2 favorable events. So 2 of them being green socks. So the favorable events over the total possible events, which would be 2/6 or 1/3.
And yeah, now here's another thing. I saw some of you typing in the chat and some of you put like 2/6 or something, but make sure when you're writing the answer to a probability problem, you have to simplify your fractions, especially in math counts. If you write an unsimplified fraction, they will actually count it wrong, even though you got the right answer. So in math counts, you must simplify no matter what.
And then Triram asked, but what if it was combined, like one green and one blue? So in that circumstance where we have two different favorable circumstances, if you think about it, we can kind of sum that up in one favorable event. So instead, if we were to pull out two socks, which I probably won't go over, there's also another relatively easy way to calculate the probability of pulling out one green socks and one blue socks if you were to pull out two socks of the 6, but we probably won't go over that right now, so you can continue, Amy.
Okay. So now we're gonna show some more examples to help show you. So Johnny has 2 red socks, 3 green socks, and 4 blue socks in a drawer. What is the probability he draws a red sock? And I would like everyone to answer because I would like everyone to get used to these types of probability problems because they're very common in math counts. And if you would, so yeah.
Yeah, so basically we expect 8 answers. Also, please put your answer only once in chat. It makes it a little more convenient for me to look at who answered and who didn't. Yes, sir. I appreciate that.
Oops, I'm sorry. Dang it. Well, I mean, now that you may have seen the answer, hopefully you can put it in chat now.
Yeah, if you've seen the answer, then you literally have no excuse to not put it in chat. Okay, I'm waiting for 4 more answers. 5 answers, okay. 6 answers. 2 more. If you're the 2 remaining people, please put your okay. All right, so we didn't really ask for green and blue, but I appreciate the initiative.
Okay. So
all right, so it looks like a decent amount of you answered. So yeah, it is 2/9, right? Because we want to draw a red sock, and the probability of getting a red sock, well, there's 2 red socks, and there's 9 total socks. So if we were to draw randomly, the probability of getting a red sock would simply be 2/9.
Oh yeah, and Udit brings up a good point. He accidentally multiplied. Now, in probability, you must remember that you're trying to find the total number of events. So in this case, the total number of events would be the total number of socks. So in this case, to find the total number of socks, you just add. So be sure you're thinking about what the problem is asking and how you would get. Oh, I'm sorry, Udip. Make sure you think about.
Is it Udip? Wait, is it Udip? Is that how you say it? Udip. All right. Sorry, Udip. All right. Nice. I pronounced it right.
Okay.
All right.
Yeah, so you must be careful not to confuse multiplying with addition. So in this case, the probability would just be the red socks divided by the total socks, which is 2 red socks divided by 9 total socks.
Yeah.
Okay, now we're going to apply this to the same problem, just to a different color. What's the probability that Johnny draws a green sock now? That's fine, Shreyam.
I also expect everybody to answer once again.
However,
because it's not.
You must simplify your answer. Yeah.
$13. I'm pretty sure you meant 1/3, but okay, nice. All right. Yeah, we know you meant 1/3. Otherwise, I'd be pretty concerned. Because considering that 1 is the greatest probability. Yeah, 1/3. All right, so it looks like most of us got the right answer. So yeah, it is 1/3. And it's simply because, well, we know that we have to draw a green sock. and there are 3 green socks, and there's 9 total socks. 2 plus 3 plus 4 is 9. So that's how we get the total socks. And so the probability that he does pull out, oh, that's a typo. It should be green
Oh
sock.
yeah, whoops,
2 over
sorry.
9 is equal to 1/3. But yeah,
Yeah.
so I think everybody, uh, most of you get probability. If anybody has any questions, can you please put it in chat or something, please? Okay, I think most of you get it. But if you do have a question, I'm gonna make a feedback form for this lesson. So remember that I make feedback forms for like almost every lesson, starting last lesson. So if you have any questions and you want me to like address them privately, then put it into like a feedback form, which I will post after the class is over. So yeah, you can move on.
Okay, so some of you have predicted that this one is asking about blue socks, which it is. So what's the probability that Johnny is going to pull out a blue sock this time?
Giftish has a crystal ball.
Now you can just write the answer.
All right, so it looks like most of you also got the same answer as the correct answer. So yeah, it's 4/9, and I think
And
we
another
all know
type
why
of
it's 4/9. I
yeah,
think we all know why it's 4/9. So
yeah,
yeah,
but I'm just to reiterate, to get the probability, we find how many blue socks are in his drawer, and then we divide it by the total number of socks in his drawer. And there are 4 blue socks in his drawer, and there are a total of 9 socks. So the probability would be 4 divided by 9, or 4/9. And that should be blue, not red. Shreem, are you asking why we add up and then divide? Oh, okay. Yeah, that's a typo, sorry.
I think like Amy's screen crashed for me. I don't know. Maybe that was just me.
Oh, no, okay. Yeah, that was that was a typo, sorry. Okay, we're gonna
All
move
right,
on
looks
now.
like okay. It looks like we had a slight technical difficulty, but it's okay. Okay, next example.
Okay, so if you look at the answers from the previous 3 problems, which were 2/9, 1/3, and 4/9, you will notice that they add up to 1. Okay?
The
Now
one is the
yeah.
okay.
Now remember that something with a probability of 1 means that it's going to happen no matter what. So if you add up these probabilities, what you're basically saying now is the probability of Johnny pulling out a sock in general. Yeah, just like Shreem said in the chat. There's a 100% chance that you will get a sock out of the drawer at all.
Well, we hope.
Because wait, sorry, did you say something?
I said we hope. Like,
Oh yeah.
like unless unless something really bad happens.
Yeah, but this is a math problem, so we're just gonna say he's going to get a sock out of the drawer. And yeah, this, and again, an event with a probability of 1 means that that event is going to have to happen. And in this case, that event is pulling out a sock. Okay, so now we're going to move on to this 4th example. Okay, Johnny has, again, 2 red socks, 3 green socks, and 4 blue socks. What is the probability that he draws a green sock or a red sock? So this is, oh,
Well, yeah, it looks like a lot of people already got the correct answer. So yeah, or in math typically means you add. So this doesn't mean blindly adding. This means using a little bit of logic and well, or right. So he can either pull a green sock or he can pull a red sock. So he could either pull 2 red socks. Well, he could either pull a red sock from the 2 red socks or a green sock from the 3 green socks. So there's a total of 2 plus 3 equals 5 socks he could pull to meet the condition. So the answer is 5 over the total amount of socks he could possibly pull, 9. So the answer is 5/9.
okay, that was good. A lot of you understand it, which is good because probability is very important in math counts. Okay. And now we're gonna,
Yeah, we're gonna be looking at independent events. So these are like
They're basically probability, except now instead of looking at one sock, instead of just drawing socks all together, we can be drawing socks one after each other, or like we're looking at multiple events that are happening after each other. So yeah.
Consecutive.
Okay. So independent events. When we say independent events, independent means that you're away from everything else and you're not affected by anything. So independent events are events that whose probabilities don't affect each other. So for
Like here
example,
I'm saying really quickly. So yeah, and so that would, for example, like that would just be like flipping a coin, right? So if I flip a coin 10 times, right, and none of those times I get heads, right, and then on the 10th time, the probability of me flipping a heads would still be 1/2, even though the other 9 times I flipped heads consecutively, and that's because a coin, because the probability isn't linked to a past events with probability. It's just like, all right, this is just a little hard to explain, but independent events are just events that don't really have like that, like events that don't like trigger something like a domino effect. They're events that don't have any effect to one another.
so yeah, like for example, your weather report might say there's a 25% chance of rain tomorrow, which means that there's a 1/4 chance of rain. However, if you also roll a six-sided die, you have a 1/6 chance of rolling a 5. But these events, they don't affect each other. Just because you roll like, if you roll a die, that won't determine the chance that it's going to rain tomorrow. So if we so these two events are going to be considered independent of each other. So if we look at an example, if you have multiple independent events, like first you roll a die and then you want the probability of a rainstorm, to get the probability of both of those events happening, you just have to multiply those individual probabilities together. So to show you how that works, let's say the probability of raining is 1/4 and you have a six-sided die. What is the probability of it raining and you roll a 5? So you can see that these two events are independent, meaning they don't affect each other. They still have their individual probabilities. So the probability of rain is 1/4 and the probability of rolling a 5 on a six-sided die is going to be 1/6. To get the probability of both of those happening, then you just multiply them together. It's just as simple as that. If the probability of event A happening is, you just multiply the probability of the first event by the probability of the second event, and that is the probability of both of those events happening. Okay. So now let's look at another example. The meteorologist says that the chance of rain tomorrow is 1/4, but the chance of rain after that is 1/2. Given this information, what is the probability that it will rain both days if the days are independent?
You shouldn't really like in a word problem, like you would never get if the days are independent. You should know if the events are independent or dependent, because like it should be fairly obvious.
And to answer Shriram's question, I don't think you divide a lot. There may be some questions where you need to divide, but mostly that's just because you've got like a whole probability, but you need to divide it into smaller ones. And it looks like a lot of you are understanding this pretty well. Yes, the answer is 1/8, because as I previously stated, to find the total probability of two independent events happening, you just multiply the probabilities together. So that would be 1/4 times 1/2, which is 1/8. Okay. So now let's look at another example. Using a standard six-sided die, what is the probability of rolling a 1 and then rolling a 2? If it were two different die, that would bring up a different issue, because I mean, if it were two different die, are you rolling them at the same time, or are you rolling them one after each other? And in that case, it would make the problem a little bit more complicated, which I'm not going to explain right now. But if you would like, we may cover something similar to that later on in the lesson, though. Okay, looks like some of you got the right answer. The answer is 1 over 36, because for this question, the probability of rolling a 1 is 1/6, because there is one 1 on a die, and then there's 6 total number possibilities. So this probability would be 1 over 6. Now, next we find the probability of rolling a 2. That probability is also 1/6, because there's 1 2, but there's 6 total number possibilities. Finally, to get the probability of both of these happening, we just multiply them together. 1/6 times 1/6, which is 1 over 36. Okay, this one is, we're gonna move past this because I think this is pretty simple too. Okay, so if you would like, you can do the next one.
All right, so the question is, if I flip a normal coin and then roll a die, what's the probability that I flip heads and roll an even number? So for this one, we have to consider favorable events. So what's the probability? We know that these are independent events. So so we need to find out the probability that I first flip a heads and then multiply that by the probability of me getting an even number.
Remember, Gary, that it's about even numbers.
Let's just let them finish and then we can explain.
Okay, Sai, I think you can go on.
So it looks like so actually none of you guys
No,
actually
several of them got
some
it.
people, yeah. So some people actually got the right answer. So all right, so what's the probability that I flip a heads, right? Well, the probability that I flip heads is simply 1/2. Okay, now so the probability that heads is 1/2, and the probability that following that I roll an even number is also 1/2. So 1/2 times 1/2 gives me a probability of 1/4. And we're gonna be multiplying it. Does anybody know why we don't add these probabilities and why we multiply instead? Or does anybody want to take a shot?
Sai, can you ask that again?
Oh yeah, sorry. I wanted to ask. So does anybody understand why we multiply these two probabilities instead of adding them? Because if we add 1/2 and 1/2, we get 1. So why isn't the answer 1? Yeah, so other than using like logic, I kind of want a deeper explanation because I understand that, like, because 1 is a guarantee, right? But let's say the probabilities were instead 1, like, I don't know. Let's say we have to flip a heads, all right, and then we can only get one number, right? We have to get a 5 on the dice, so the probability would instead be 1/2 times 1/6, which would be 1/12, right? So And so why would we get 1/12 instead of adding 1/2 and 1/6?
Sorry, I think you should just explain.
All right. So yeah, I was wondering if anybody could. Okay. All right. So imagine it this way. All right. So I'm gonna be multiplying these two events because all right, this is actually a little trickier than I thought to explain.
It's
Here,
because they're happening one after the other. And
because they're independent. All right, because they're not okay. Here, actually, independency has really nothing to do with it. But like, this is actually a little more difficult. But here,
it's because the reason we would add an event together is because they're different versions of what could happen. So for example, if you're going to flip, yes, it's because it
and
says
yeah,
and.
because it's and. So by having that and, right? Because like it's one event, all right. So when we're adding two things, it's because it's like two different varieties of what we could get in one single event. But flipping a coin and then rolling a dice, those are two separate events. So we can't add them together to get the right probability. We have to multiply them because that gives us the total amount of iterations, right? So if I had four possible, I have six possibilities on the die, right? And I have two possibilities on the coin, right? So I can't add 2 + 6 to get a total of 8 possibilities, right? Because I could get a head for all six of the numbers on the die, and then I could also get a tails for all six of the numbers on the die. So I would have a total of 12 possibilities. So that means I can't just add 2 + 6, right? Because that wouldn't give me the accurate amount of total possibilities. And so for that reason, we multiply. In that same way, the total amount of favorable events, we can't add the favorable events because they're two separate events, and they don't give us the correct number of iterations or the correct number of total possibilities for the amount of favorable events. So that's why we multiply instead of add, and that's definitely a little tricky to understand. So I actually don't expect you to get that at all. But that's generally it. These are two separate events, and since these separate events have separate like outcomes and separate favorable events, you can't add them because they're not because when you add something, you're adding them from the same event. You're not adding them from like a different event. So two different events means you almost never add in two separate events. But yeah, it's a little tricky to completely contextualize in like a simple way.
Just
So
remember that if events are happening one after the other and you're trying to get the probability of both of them happening, you need to multiply the probabilities together, especially when it says like and in the question. Okay, so for independent events, it was actually independent events are a little pretty straightforward because you just need to multiply the events together as long as you know their probabilities. However, for dependent events, dependent events are different from independent events because in dependent events, one event can influence the outcome of the second event, which means that the probability of the event changes. So when calculating the probability, you have to take into consideration the changes caused by the outcome of the first event. So here's some vocabulary that are pretty important in probability problems. First of all, if a question says that an object is like, if a person does something, but then, for example, like pulls a sock out of their drawer with replacement, what that means is that after that person took the sock out of the drawer, they put it back. they replaced it and put it back into the drawer. Now, the opposite of that is without replacement. What this means is that after the person pulled out a sock, they didn't put it back into the drawer. So now there's a sock missing, but they're continuing with the probability problem. Dependent events usually occur when it is without replacement, meaning that someone drew a sock and then they drew another one without putting the old one back. And this without replacement, this kind of complicates some probability problems. So here's an example. If Johnny has, again, 2 red socks, 3 green socks, and 4 blue socks in a jar, and he pulls out 2 socks, one at a time, without replacement, what's the probability that he pulls out 2 red socks? For this problem, you can't just do it the normal way. You can't just find the number of red socks and then divide it by the total number of socks. This is, okay, that answer is unnecessary, but this is harder because after Johnny pulls out the first sock, the number of socks in the drawer will have decreased by 1 because Johnny didn't put back the sock. In addition, if Johnny first pulled out a red sock, the number of red socks will also have decreased by 1 because he didn't put it back. So even though both times Johnny is pulling out a red sock, the probability of pulling out a red sock each time has changed. And that is exactly what a dependent event is. The second red sock is dependent on the first one because the probability changes. To solve this problem, you have to find the probability of each event, and then sort of like the independent events, you have to multiply the probabilities together at the end. So first we need to find the probability that Johnny pulls out a red sock on his first try. So because there are 2 red socks and 9 total socks, the probability that he pulls out a red sock on his first try is 2/9. Next, we need to find the probability that Johnny's pulling out a red sock on his second try after he has already pulled out 1 red sock. If he's already pulling out 1 red sock, then that means he would have 1 red sock left and 8 total socks left. So that probability would be 1/8. So finally, to get the probability that he pulls out 2 red socks overall, you multiply them together as usual. 2/9 times 1/8, which is 2/72, which is, you must simplify to 1/36. This may seem a little long. You just have to remember that you must find the individual events. You need to find the probability that he first pulls out a red sock, and then you need to find the probability that he pulls out a red sock after that. Okay, so now we're going to move on to another example. Oh, yeah. Sai, you can do this one.
Yeah, I was just gonna ask if anybody had any questions. All right, so okay, looks like we don't really have too many questions. So, dependent events. So, you can see that in previous problems, we kind of found the probability of each event, and we multiply them together at the end because but those were all independent events or independent probability. But dependent probability is kind of like it's similar, but we have to be more careful because the probability changes every time we calculate for an event. The probability will change. So just like the previous problem, the probability changes, right? Because we're removing some socks, right? So the probability that we get a red socks becomes different than the probability initially, and that's why dependent probability problems are just you have to be a little more cautious of because they can be they can just be a little trickier to deal with. All right, so now we're gonna move on to an example. So Johnny has 2 red socks, 3 socks, 3 green socks, and 4 blue socks in a drawer. Johnny pulls out 2 socks without replacement. So what is the probability that he pulls out 2 matching socks? And also I wanted to clarify that he's only pulling out 1 sock at a time. So that's actually not stated clearly on the problem, and it actually should be, because 2 socks without replacement could just mean pulling out 2 socks at the same time.
Yeah, it
So
should be one at a time. First pulls out one sock and then pulls out the next one.
yeah, another sock. So that actually greatly changes the probability of 2 at a time. It's a completely different problem.
Yeah, but we're not going to cover that this time.
Yeah. Wouldn't that be 4? Wait, sorry. Yes, 2 matching pairs. Matching socks. I said matching pairs. All right. So do we have any answers? I don't expect too many people to get this problem.
Oh, here's a hint for this problem. I hope you guys watched the video I posted last week because it involves casework. And the best way to do this problem is to use casework. And well, at least the way we're going to show you. This may not be the best way to do the problem, but one way to do this problem is to split it into cases. Like first, find the probability he pulls out 2 red socks. Then find the probability he pulls out 2 green socks. Then find the probability pulls out 2 blue socks, and you can add them together at the end.
All right. So I don't think we have any answers, and I think, and this problem is actually really difficult.
Yeah.
Beyond simple probability, it's really difficult. So I actually a number of ways to attack this problem. So the way that I would prefer would be casework. So I'm not saying this is the easiest way. It probably is not the easiest way to do this problem, but it's the way that has kind of like the least margin of, okay, the answer's there. All right, kind of least margin of error. So casework, right? So there's 3 different cases here. All right, the first case. Okay, yeah, great. We're doing casework. Amazing. So the first case is that he pulls out a matching pair of red socks. So keep in mind that there are 2 red socks, I believe. So we have 2 red socks, right? And there's a total of 9 socks. So the probability of drawing a red sock in the first draw is 2/9. And after we draw that red sock, we only have 1 red sock left and then 1 less sock. So instead of 9 socks, we only have 8 socks since we already drawed one. And instead of 2 red socks, we only have 1 red sock since we already drawed one of the 2. So does everybody understand that? That's like really important. No answer. Amazing. All right. So we get 2/72, which simplifies to 1/36. So that's for the Red Sox. All right. And let's move on to the Green Sox. So we know that there's a total of, I think it's a 4 or 3 Green Sox. Like
I think it's 3,
right? Yeah,
three.
3. Yeah. So there's a total of 3 Green Sox, right? So the probability that we get it's 3/9, right? Because there's 3 Green Sox and total of 9 socks. So the probability that we pull out 1 Green Sock is 3/9. And then now after we pull out that Green Sock, there's going to be 1 less sock and there's going to be 1 less Green Sock. So we're going to have 2/8 for the second probability. So we get 6/72, which simplifies to 1/12, or 3/36. Now for the Blue Sox. So we have a total of 4/9 on the first draw and then 3/8 on the second draw, which makes for 7/72. So once we simplify everything together, that'd be 7/72 plus, I believe, 6/72 plus, I haven't really, yeah. So it's 2/72 plus 6/72 plus 12/72. And we get a total of 20/72, which simplifies to 5/18. So that's the answer.
Yeah, this is a little bit harder than all the previous ones you've seen. But
The trick to this is just
yeah.
casework. the trick to this is to break it down. So attacking this as a whole will be really complicated. So you kind of just have to break down the problem and like break it into easier chunks. So the first easiest chunk would be, okay, let's break it down. We first broke it down into 3 different cases, all right? So immediately the problem becomes easier. Then we break down the first draw, the probability of getting the first draw, and then the probability of getting the second draw. And then we combine everything, and then the pieces fall in place for us to get the answer to the problem. So this problem is actually relatively easy compared to like in the entire scale, like compared to like the difficulty of probability problems that you will surely encounter while taking like a school or state math counts test. So this problem is actually relatively easy, but that's only because we were able to break it down into these different manageable chunks.
Yeah, that's a good strategy for math counts, to break problems down into small parts.
And casework is like a huge part of probability. It's one of like the main strategies that a lot of people use. So yes,
Yeah.
casework. Practice that. All right. I've seen problems like this. Oh, okay, yeah. Trainer. So you're probably referring to math counts trainer, right? Yes. Okay. So yeah, I wanted to tell you guys about this resource. It's called Math Counts Trainer. So you guys can definitely use that. It's a really, really, really good resource. I actually used it throughout my entire time in middle. Yeah, it's on AOPS. I actually used it throughout my entire time doing math counts. So there's gonna be 4 levels on because there's like a school level, a district level, a state level, and a national level. So actually, it costs nothing.
No,
It's free. It's
nothing,
free.
nothing on AOPS except for their classes. Nothing on there costs anything except for the classes.
Except for the classes in the books if you're gonna order the textbooks. But yeah, it costs nothing. And I was able to get I was able to max out everything. I was able to get 42s on all 4 levels, including the national level, and that's just because I was able to practice. So I definitely recommend doing Math Counts Trainer. Like
Yeah,
that will help you so much. It helps your problem solving by a lot. It's actually probably one of the greatest resources for me.
yeah. It provides a lot more a lot more practice. And for math counts, you just need to have a lot more practice. Do minis help? Yeah, minis help because they introduce a specific topic, sort of like we're doing right now, except the minis do go into a little more detail into these topics,
But
which
if you
will
but if
definitely
you
be
want to
helpful.
But if you want to practice, okay, so for the win, for the countdown runs, yeah, it's also good. But if you want to practice like specific concepts, I definitely would refer you to Alchemist because Alchemist lets you choose specific concepts and lets you practice them, and it's just really nice. And then you can do for the win for countdown. Except sometimes for the win problems are generally like much harder than like the actual countdown round like
Yeah.
problems. They're like they're not nearly as hard as the actual math counts countdown run problems. But yeah, so I suggest that you do
Oh,
all the things that Shani put. All right, so now we're gonna do a Kahoot, everybody. Yeah, but remember, like math count trainer. So yeah, you should probably do that.
oh shoot.
What happened?
I forgot how to do it.
All right, I'm gonna join the Kahoot for fun as well.
Okay.
I just want to see. I'll join for fun. There's like no.
You can put whatever name you want, just as long as it isn't like rude or bad.
Can we do team mode?
Oh, team.
Nah.
I'm not sure we'll be able to do.
Individual. Let's just do individual. I'm gonna join the Kahoot with you guys.
This Kahoot isn't going to have the hard problems. These are going to be pretty easy ones, I think.
Beats me. All right, looks like we only have 3 people, 5 people. I think we should have like a total of 10 people. Yeah, 10.
Yeah.
Unless another instructor decides to join. I'm gonna put the pin in chat.
It's already in chat.
Oh, nice. Okay, I'm gonna put it again because actually no one new joined, right? So yeah, never mind. All right, 7. Looks like we have 8 people. I think we're waiting on 2 more.
One second, I'm almost in. I just had to go get my Chromebook.
Okay, we can wait for you.
Well, we will wait for you. I think, let's see here. So, is you deep on there? Who is Thomas in the car? Can someone tell me who Thomas in the car is, please? And why? And like, I don't know. I kind of expected Thomas in the train, you know? Thomas in the train, Thomas in the car. Wait, so who is Thomas in the train? I'm just gonna look.
Okay, I don't know. I
I
think
think we
we're
have
waiting.
mostly everyone.
Yeah.
I think we're waiting
Okay,
on one more person.
No, there's only 11 people now, so I'll just hit start.
Yeah, you
All
start.
right. All right.
Oh, this is so hard. Bro. My jitters are back. My Kahoot jitters. I get so nervous.
These are pretty easy problems. I'm just gonna say that.
These are pretty difficult problems. You guys got this. Come on. Your ultimate goal is to beat me. That's your number one goal.
Yeah, try to beat Sai. Okay, so it looks like most of you got the right answer. Just remember that this is asking about the probability of an odd number. And the numbers are on the die 1, 2, 3, 4, 5, 6. And of those numbers, 1, 5, and 7 are odd. So 3/6, or in other words, 1/2. Oh, of course.
I'm Oliver, that's not me. It's like you look like it's clearly not.
Okay. Second question. This is a little harder. What's the probability of rolling a multiple of 3?
How many people on the Kahoot? 9, yeah. I think all 9 people answered, Amy.
Okay, again, it looks like most of you got the answer right. Oh, there's 10 people, Sai.
So 10. Okay, my bad. Okay, so the multiples of 3, right? So the only multiples of 3 would be 3 and 6, right? So that's a total of 2, and 2 out of 6 would be 1/3. So that's how you would get that answer.
Okay.
Well, like someone's 20 points below me.
Well, last, I'm hoping last is going to end up being first.
I'm gonna do it for okay, yeah, let's see.
The probability of rolling a number less than 10 on a standard 6-sided die.
Wow, looks like a lot of people answered at the same time. 4 people answered at the same time. Kind of like a trick question. Not really.
Yeah. I mean, it sort of is. It's just
sort of. It's just
a little.
Like, it's just something that you wouldn't expect.
Yeah. Okay, it looks like 8 out of 10 of you got this right. So this sort of was a trick question. What's the probability of rolling a number less than 10? All of the numbers on a standard 6-sided die are less than 10. So because you're guaranteed to because you're guaranteed to have this happen, the probability would be 1. And just a reminder, 0 means it's impossible. Oh, wow. Okay, well, yeah. Okay, what's the probability of rolling a negative number on a standard 6-sided die?
You made this too hard.
Yeah, I'm sorry for making it too hard.
This is actually pretty easy.
What are you talking about, me? This is like so...
No, standard die don't have negatives.
So honestly, it actually is a pretty easy Kahoot, but like these, you have to be like on guard for these trick questions. So in math counts, you don't really expect any trick questions. Actually, yeah, you really don't. There really aren't any trick questions in math counts. I've actually never seen it really a trick question, but there are some really easy questions. Like one question was like, remember like that chart question? Remember the airport question, Amy? Like the miles from Boston to Chicago, and then they had the answer on the chart.
Oh, that.
Yeah.
Oh, yeah.
But
Yeah,
math game has a lot of other like trick questions. It's not like math counts.
Yeah, but
Math counts
you do have to be careful not to make silly mistakes on the
mistakes.
easy
Yeah,
ones.
that's true. That's true.
Okay, for the rankings. Well, it looks like Sai is still in the lead. Okay, the integers from 2 to 10 are placed in a bag. One number is chosen. What's the probability that the number is prime?
Probably gonna get this wrong. Oh, bro, I don't even know the answer. What is it? 2? Oh man, I actually don't know the answer. Well, I actually forgot for a hard second. Yes, so you actually have to take it slow, like, to get the answer right. So I'm gonna go over this really quickly. So the numbers between 2 and 10. So remember last lesson that we learned how to find the total number of integers in a consecutive list. So we take the last number, subtract it from the first number, and add 1. So 10 minus 2 is 8, and 8 plus 1 is 9. And like Ashani said in the chat, so graciously, she gave us all the prime numbers from 2 to 10. 2, 3, 5, and 7. So there's 4 prime numbers, and there's a total of 9 numbers. That's how we get 4 over 9. That took me way too long. So I think someone's actually beaten me. I hope someone's beaten me.
Oh, yeah.
Yes!
Last
You
is
are
in
my
first place.
successor. You are my successor.
Okay, the image shows a dartboard. What's the probability that a dart thrown will land in a gray region? Yeah, this is a different type of probability problem.
Oh, also, the lines don't count, so just don't include the lines. But yeah, this is pretty straightforward. This is pretty easy.
Okay, yeah. Here's the
Looks like everybody
dartboard.
got it.
Each square is about like 1/4 of the.
Amy, everybody got it right, so I don't think we really have to go
Oh
over
yeah,
it.
I did. Whoops, I didn't see that.
Yeah,
Well,
okay,
either.
well, you got really lucky then. Okay, it's fine.
Yeah. Okay. Okay, it looks like last is still in first place. Sorry.
Wait, did it not update? I feel like no. Oh yeah, okay. It took some time to update. It was like really like weird. All right.
Okay.
Oh,
The 2 letters of the word math counts are chosen at the same time. What is the probability that they are both vowels?
how many words are in?
Oh shoot, I may have messed up on this question. I just realized.
Yeah, that's actually wrong. Yeah. Amy, I think what you intended for this question might have been wrong because like.
I was changing it, and then I don't think I fixed the answer. So I'm
Oh
sorry.
man, yeah, it's fine.
Oh well, actually, I got it. Okay. It looks like most of you still got it
Okay,
right.
so
Okay,
yeah, we got
actually,
the right answer, but it's the
yeah.
wrong answer. But we're just gonna skip this question and move on.
No, this is. Oh.
Yeah, it's
Yikes.
definitely.
Yeah, this is wrong. I'm sorry, people.
First of all, there's 3 vowels, and then like even if we were to suggest and like so it would be 3 choose 2, which is a total of 3, and then assuming that they're all different.
Whoops.
And yeah, no one got the right answer. Technically, no one got the right answer.
Yeah.
And then
Yeah,
it's fine.
sorry.
It's fine.
Oh dang it. Okay.
Don't worry. So the actual correct answer is, let me calculate that. I think it should be like around 1/15.
Yeah, that was one of the answers. I forgot to change it to that. I'm sorry.
It's 1/15 because 3 choose 2 over 10 choose 2. Yeah.
Yeah.
I was looking for 1/15, but I couldn't find it.
Okay, the probability that will rain is X. The probability that will not rain is Y. Is this statement true?
First answer. Wait, is there nothing on Kahoot that lets you know it's the first answer? That'd be kind of cool. I mean, it depends on your points. I'm pretty sure you get more points like the faster you responded, right? Isn't that how it works?
Yeah. Okay, good job. Almost all of you got it. So the
Gary drizzling is raining, like if you think about it.
Oh, my window's closed. Well, for this question, the probabilities have to sum to 1 because
but hail's not like hail. Okay, hail is not rain, right? So
well, either way, whether it is rain or is not rain, it will either rain or not rain.
And also, like, never overthink the problem. Like, never just don't do it because, like, If you,
Yeah.
yeah, just don't. Okay, next.
Okay.
I need to see if I'm number one again.
Nope.
Oh no, last.
Okay. Event A has probability of X. Event B has probability Y. The probability of both events happening is.
Remember what I told you guys. These are separate events. Remember, if there are separate events, then we don't add, we multiply.
Well, great. You just told us the answer.
Yeah, but 9 people already answered.
Okay. Yeah.
And I'm pretty sure last was one of those 9 people.
Yeah. It's Y times X. Remember that for independent events, for this one, event A and event B are independent. So to get the probability of both happening, we would multiply them. So it'd be X times Y.
Yeah, like Ishani said, well, something like that. Oh man, this is so sad. And 266 points behind last. Okay,
Two
I
fair
will try
coins
my
are
best.
flipped. What's the chance of flipping 2 heads?
Wait, is last Ishani? Ishani, are you in the game?
Yeah.
Yeah, I knew it. Last is Ishani. I told you. Yeah, that makes sense. All right, because it's really hard for them to consistently get these. I knew it. I knew it. You see, I purposely slowed down a question just for last to get on top, but it turns out last is Ishani. It's just not I purposely let you. I actually purposely held back the time I took to get a question because I thought I would make a kid's day. It turns out it's just Ishani. All right, move on.
Okay, well, for this one, flipping 2 heads, the probability of flipping heads for 1 coin is 1/2. So flipping 2 heads would be 1/2 times 1/2, which is.
Because remember, these are
1/4.
2 separate events. Right, we're flipping it on 2 separate occasions, right? So we're gonna have 1/2 times 1/2, 1/4, because we multiply with 2 separate occasions. Also, these actually help you with countdown because thinking fast really helps you, in things like countdown. So yeah. The coin has 3 sides. Really? I didn't know that.
I mean, if you count the side, yeah.
Oh,
In fact,
one
of the slides I actually did, we didn't go over this in the slideshow, but after the lottery slide, there was a slide asking you to find the probability of a coin landing on its side. It's a thing.
wait, it's 5:59. I think we should almost.
Oh yeah, we should hurry.
Yeah.
Okay, you flip 2 fair coins. What's the chance of flipping a heads and a tails in any order?
Oh, I'm so done. I think I got it wrong.
Oh, that was quick.
I got it
Except
right.
it was okay. Well, it looks like only a third of you got it right. So I'm going to quickly explain this. 2 coins are flipped. You can either flip heads, tails, or tails, heads. There's actually 2 different ways you can do this. So the probability of flipping a heads and a tails is 1/2 times 1/2, which is 1/4. And then the probability of flipping tails heads is 1/2 times 1/2, which is 1/4. So 1/4 plus 1/4, the total probability would be 1/2.
And also another way that I did it, right? So the heads and tails in any order. So that any order should be kind of the cute thing about, all right, there's multiple ways to do this. So the probability of getting 2 heads is 1/4. We went over that in the last problem. And the probability of getting 2 tails is also 1/4. So that means there's a 2/4. So the probability of getting both heads or both tails is 1/2. And the only thing that's remaining is getting mismatched heads and mismatched tails. So the only thing remaining would be 1/2. So that's another way to do it. That's a different kind of probability. I think it's like complementary counting or something. I forgot what it's called. No, it's not complementary counting. It's where you exclude or you calculate for like the opposite.
Yeah,
like,
that is complementary counting.
Yeah, it is complementary counting. Okay, yeah.
Okay, we're gonna have to go on to the next question now. Last question.
Last question. Oh no. Last is
3 dice are rolled. What is the probability that the numbers on the top face sum to 18?
I'm the first answer.
Of course. I mean, we could probably guess who those first 2 answers were. Okay, this question may seem hard, but you just have to think about it.
Yeah, the only way I win this is if Ishani gets like the answer wrong.
Oh, it looks like most of you got it. Okay.
Job.
So
Okay, so just to clarify, the most we can get on a die is 6. Remember that. So if we have 3 die, the most we can get is 18. So then we have to get a 6 on every single one of those 3 dice. So it'd be 1 6 times 1 6 times 1 6, which is 1 over 216.
yep.
Job to the people who did get that right. And I understand that you guys don't have a lot of time on Kahoot, but this actually really helps you develop like a faster pace, and it actually helps you in the countdown round. And yeah.
Oh, well, you could just assume it's 6 sides. If they say dice, they're probably 6 sides. If they don't say
Amy, didn't you make the set?
it. Make what?
Didn't you make the Kahoot set?
Yeah. Okay, good job.
Hey,
Good job, Udeep.
It's you, Deep.
Yeah. Well, I mean, okay. Or no, it's not. Oh, is it Shreyam? Sorry, I thought someone said they were. Oh, I got it mixed up.
All right, just so you guys know, last didn't genuinely win. All right, I purposely held back.
Okay, so good job to everyone. You can leave now because it's 6:03. So